Hi, I hope that you've been enjoying these three shows on what space architects do and their significance with the designing of space habitats for human space travel. I'm Vince Mickens, and this is All Things Aviation and Aerospace. As we wrap up the series with the third interview, it's important to note that it all starts with education, and that's where Dr. Olga Bannova fits in. As the director of the Master of Science in Space Architecture program with the Sasakawa International Center for Space Architecture at the University of Houston's Cullen College of Engineering, Dr. Bannova talked with me about their unique program and incredible opportunities it provides for the next generation of space architects. I hope you enjoy our conversation as much as I did. Dr. Bannova, welcome to the show.
Thank you very much. I'm happy to be here and talking to you, Vince.
Yeah, thanks. It's great to have you here. I'm very excited about our conversation coming up. Just talked with Dr. Howard and got some perspective on it. But what's great about your side of it is the education side, particularly at a university that has a program that's one of the few in the world, actually, to that's specific to space architecture. As we were talking about, I was talking about that with Dr. Howard and mentioning to you before we switched over that space architecture is kind of a new term, even though it's been around since space exploration began. But now it's the term for describing the whole thing about habitats in space and things like that. So I think it's pretty interesting, and I really want to dive into it a bit so that we can give our audience an idea of what space architecture, not only what it is, but what the opportunities are with it in terms of how you steer your education that direction and things like that. Why don't we start out a little bit and you tell us about your background, your education, and your path to where you are now?
Okay. One correction, actually. So the Master of Science in Space Architecture is still the only one in the world. It's the only degree. So there
Wow.
are different programs when they teach, and students, usually architecture students, are learning about space. And usually it's still within their architectural curriculum. But a degree, Master of Science in Space Architecture, recognized by Texas Higher Education Board, is the only one in the world. So we're still very special.
Yeah, it is. So talk about that a bit. Tell us about how space architecture has evolved.
First of all, I learned about the center when I just arrived to Houston and started my master's program in architecture here at the College of Architecture at the University of Houston. It was some ancient times when the websites weren't very common and the internet was, of course, around, but it wasn't at the same level as now.
Sure.
So I only learned that center exists when I came to the school, actually. And I was always interested in space and all.
Okay, so you were interested in space, but you didn't know there was such a thing as space architecture?
No, I didn't. And at that point, it's still quite few people were working on projects related to space and looking at space habitats, designs from architectural point of view perspective. But it wasn't that much recognized as it is right now. And
As something specific.
yeah,
So
so
let me backpedal a little bit with you. And you studied architecture before you came to Houston, correct?
yes. Mm-hmm.
Okay. And you've always had a thing about space, so to speak. So was Houston what put the two together for you?
Absolutely, yeah. So it's again, probably it's how it happens. Like if you even consciously or unconsciously set up and look in it, so that's the first thing that you notice. And that was the first thing that I noticed about the College of Architecture, that this center is here. the program wasn't established yet, but the Center for Space Architecture was already here.
So you were excited about that when you saw that?
Yeah, so that was something, because I was always interested as architect in working on very complex projects. And in my mind, it was all urban big scale projects, putting things together and connecting dots together on this global scale and on the very complex scale was something that's very exciting and something that architects can do. And again, what more challenging it could be than designing for space, right?
Absolutely, because of the environment, et cetera. So, and what a great challenge. So, tell us a little bit about the center and then how that transitioned into a program to where it is now a graduate program there.
Yeah, so two major things happened in 2002. One was that International Astronautical Congress was here in Houston, and this is the largest gathering, the largest event in space industry. So when all agencies and industries and academia usually present and talk to each other, and it's a week-long event, and that travels from city to city, country to country every year. So it was 2002 when Houston hosted it, and that thing happened. And then before that, or actually on the same year, we had a group of engineers from Johnson Space Center who came to the center, Sasakawa International Center for Space Architecture, and they said that they want to learn about space architecture. And they want to learn about architectural approach, architectural methods, and they want to work on the Mars project. At that time, it was first wave of Mars exploration was announced and that we're going to Mars, and then all the settlements on Mars projects and ideas were brewing and flourishing, or started flourishing then. So those engineers came and said that they want to learn about it, they want to be part of it, but in order to work on their project and learn and participate in classes, they have to get a degree. And so NASA would support their studies.
Gotcha.
And that's how we kind of very quickly put together a program, a curriculum for them. And while they already started taking classes and working on this project, we were working also on making this degree approved by the university first, and then by the Texas Higher Education Board. So that happened in 2003. So when they graduated, they were first Master of Science in Space Architecture graduates.
Got you. And all of them, they had different types of engineering degrees, or a specific engineering degree?
Different, yes.
Different ones.
Mm-hmm.
And now they have a graduate degree in space architecture. And that program has been going, you said, since about 20 years now.
Yeah, exactly. We're celebrating 20 years this year.
Yeah. That's pretty interesting. So, and you've been director of the program for how long now?
Since the center was moved administratively from architecture to engineering, and that happened. Finally, it was finalized in 2014, and rather beginning of 15. And at that time, Dr. Bonnie Dunbar, was director briefly. She was at that time at the University of Houston, and thanks to her, the program was moved to transition into engineering. But then she left to TAMU, and I became a director in 2016.
Gotcha. So this is pretty interesting, and I love the track that you have, so you can even explain it better of the discovery you made and the transition you made in terms of the graduate program for space architecture. All of that said, what do you share or recommend to students that may be engineering students, et cetera, that now are maybe an architectural student, but realizes that they could actually do something called space architecture?
First of all, you have to have that passion for this, for design. And that's usually when somebody asks me about the program, a potential applicants, that's what I tell them. So should be interested in human space flight. You should be pro human space exploration and excited about designing for humans. We do it for people, right? So as architects, that's people, our clients.
Yeah.
That is, we need to think about all aspects of human life, but at the same time, we should really respect and satisfy all the requirements, engineering requirements for systems to supporting also human life, supporting whatever activities they have to perform during their mission, but also provide support for the engineering part, for their spacecraft, right? For their
Right.
space habitat, thinking about infrastructure if it's on the surface. So how it's all part of the bigger infrastructure, how it's a part of future growth, what will happen next. We are not completely done with 13 missions, but we want those 13 missions become a part of some sustainable presence on the surface of Moon or Mars or elsewhere.
Right.
Uh,
Exactly.
so that's something. That's what I usually tell them. And our program is multidisciplinary, so we have engineers and architects and industrial designers, product designers, because also students are coming from all over the world and with different types of degrees. But you should be interested in design. You should be able to understand or have this desire to understand and learn about these complex systems and how you put it together and how it will work for supporting human operations.
Right.
And
Yeah, the complexity of it was something that I talked with Dr. Howard about, and just in general with what you're saying too. It actually takes a pretty large team to put something together that's a habitat for whether it's an orbital habitat or something on a planet. And one of the things that we talked about was you have to be, as you're talking about, aware of what will protect the humans that are in these habitats, both whether it's on the planet or in orbit, because one of the big factors is we have an atmosphere that protects us here on Earth, but you don't have that necessarily and maybe you can speak to that.
oh yeah, absolutely. Of course, safety is the first thing, and protection from all the hazards in space, so on the surface of other celestial bodies. Let's put it this way, in general.
Right.
So that's the must. All right. But also considering what is happening inside the habitat or inside those pressurized structures where people are, that has to be also safe and ergonomic, of course. It's part of it, it's part of human factors. But it's also should be convenient and responding to their needs during the long period of time. If we're talking about long mission, so things are changing, the environment may be changing, their tasks may change. So humans should be able to interact with their environment and also improve it if it's needed or adjust it to their needs and their desires and their liking some point too. So that is part of it as well. So we always considering protection, of course, as a major thing. Has to be pressurized. We have to provide some radiation protection. temperature control, and all of that. That is just survival. But then we're thinking about living, and then we're thinking about productivity of the crew, and also their physical and psychological health, their cultural background, social interactions. There is such a term as crew or team resilience, and that is very important to support that as much as possible, because then they will be able to respond to different situations and dangerous situations or whatever. So when they will need to make a decision very fast. And if they go farther and farther from Earth, they will get less and less immediate support from the mission control, let's say.
Right.
The time delay is a real thing.
Especially going to like Mars as an example.
Yes, absolutely.
Where it could take up to 6 months.
Yeah, even on the moon, if we're talking, for example, medical operations and medical situations. So if there is some serious surgeries happening, or it has to happen, and the crew or doctor will have to have support or advice from Earth, delay even in few seconds can be too much.
Right. No, that makes a heck of a lot of sense. So it also says that you can be a space doctor. You can be a doctor and go with the crew out there to the moon or to Mars. A couple of things that come to mind. One, as I was going to ask you, is there any specific collaboration that your College of Engineering is doing right now with NASA?
Well, there's a faculty, they work on different projects related to NASA, and one is with robotics. Can't tell you exact names, but it's always something that goes on the UH campus. And the SAM, so natural science and mathematics professors, work with Johnson Space Center, quite a few of them very closely. Even in geology, there is professor in geology department who worked on Mars geological.
Right, and I know there's people out of JPL also that are working with that are geologists that are working on things like that.
Yeah, and radiation issues too. So Professor Dr. Pinsky is also working on this long-term project with NASA, with Johnson Space Center. It's going on constantly. So
well, I on the radiation side of things, I mean, a long trip to Mars in open space, so to speak. I understand that radiation is a major concern as to how to keep that in check or mitigate that to protect the astronauts. I wanted to ask you about your curriculum there for the graduate program. Just a brief overview, if you could, of what the curriculum consists of for your students.
Well, we have required, of course, it's we called it Steel Studio. It's inherited from architecture. And this is project-based studio classes where students working first semester, they work, new students when they join, so they work on a team project, and it's 1 semester project usually. And then they continue on with deciding on their master thesis project and started doing their research. It's a short program, so if you do it full time, and there's a speed that is suggested for these full-time students, it's just 3 semesters, 30 hours. So second semester is research oriented, and then the concept development semester, and then the final semester is when you finalize your design, your master project, and basically write thesis and present your thesis and like that. So classes, we have about, of course, habitat systems and integration, and another one is mission planning and design influencing factors related to mission planning. But it's really hard actually to separate one from another, even though our classes,
they kind of overlap.
Yeah, because it's again, you cannot design a good habitat that is disconnected from understanding of mission needs, crew size, obviously, the direction of the mission, then also why you're going somewhere. So again, purpose of the mission goals and objectives at different stages of the mission as well. So the question why is always the big question, and it's always emphasized to the student that you have to ask this question yourself all the time. So why, and test and analyze your own theories or concepts from that perspective. So I'm trying to teach everyone with this, of course, critical thinking, and really follow that logic of, cause and effect from design point of view. So if you suggest some decisions, so see how that will affect the whole system or maybe the whole mission. So where you go with it, and that's the major thing. So also now that talking about like what Dr. Howard mentioned, that it's a big team of professionals, architects, engineers, designers, scientists working on the project together, designing a habitat, let's say. And the same thing in our studio, in our classes, the group of students with different backgrounds working together, learning from each other and learning each other's language so they can understand and listen to each other, and not dismissing somebody's ideas just because you either don't understand or don't think it's not that important. Everything is important. It's almost equally important.
Sure.
When you design a space mission and you want your crew safe and sound and return back not only physically healthy but also mentally healthy.
Absolutely.
Totally liking each other.
So the team projects that your students work on do they tend to be related to what's current in terms of the moon and Mars and things like that?
Absolutely, yeah.
Okay. Yeah.
Okay.
That'd be pretty exciting to do that. I know if I were doing a graduate program like that, I would want to do something that was relevant to what was happening today, with the moon being the first stage of that, and the next one being Mars. Speaking of that, we were talking about, so the moon is in relatively close proximity as compared to the closest planet at a certain orbit, like Mars. Much of a difference between what you work on or focus on, I should say, for those two, what did you call them? Celestial bodies?
They're all celestial bodies, right?
Yep, exactly.
Also, of course, moon is can be and is considered to be a big test bed for Mars missions, but conditions are very different from many perspectives, and that's part of again the design challenge usually. So to see what is different and what are the influencing factors for the design, and what comes from the environment. There are also design influencing factors that come from the crew and mission objectives and mission needs.
So go ahead.
No, well, so obvious differences between Mars and the moon is atmosphere. There is still some atmosphere on Mars, right? It's thin, but there is atmosphere. The pressure, there is atmospheric pressure. It's very low, but still there is atmospheric pressure. Landing something on Mars is more challenging than landing something on Moon, and the same thing launching from it too. Not even talking about the distances, how you get there, but even these landing launching operations are different. Then again, regolith on the Moon is different from regolith or ground on Mars, right? The dust on Mars.
Right.
So different quality and different ways of how it can affect surface operations.
Yeah, I was just thinking about the fact that also, so a lot of the information, like the Mars rover that's currently there, that's been now there for a couple of years and continues to send back information. Plus, it has geological information that will be our geological samples that will be brought back in a few years. Apparently, it takes quite a bit of time to get that stuff back here from Mars. But my point is about the information the data and information, does that play a large role for what you guys do as space architects in your designs and systems?
Absolutely, yeah. More data you can get is better. That's the major issue with designs and working on designs for Moon or Mars or else. That the lack of solid ground information. So we have to make a lot of assumptions, and
Okay.
that is again understanding the limitations of those assumptions, or those assumptions posed to the design solutions.
Yeah, calculated assumptions, right?
Yes, yeah. So we don't know. Yeah, so more we will be exploring, more we'll know. And of course, once first missions will be there, and hopefully the first habitats will be there, then when the real learning will be happening, when actually those operations will be in situ.
So as we kind of wrap things up, one of the things, as I mentioned before the show and also during the show, is that our audience are exploring what opportunities might be out there for them in the industry on the aviation side and on space exploration side, and being a space architect or becoming involved in that is really a unique and very specialized and great thing, I think. From your perspective, your experience and all that you have done, and having students that you stay in contact with that have graduated, students that you have currently, et cetera. For somebody a parent or a student in middle and high school that are, kind of thinking about what they may want to do, they're interested in space or they're fascinated by it. What kind of feedback or advice do you have for them as they start to try to move forward?
Oh, well, again, this follow your passion is the first thing. And then
Follow your
just
passion. That's your number one, huh?
yeah, that's number. You got to love what you're doing. Life is too short to waste it on something, and we spend way too much time working. And if you don't like what you're doing, it's torture. Why torturing yourself?
True. Very true.
And feel sorry for yourself. And it's not productive at all.
Yeah. Yeah.
So that's a major thing. But actually, right now it's getting more and more exciting to be in the industry and work with the project.
Absolutely.
And commercial spaceflight, I really wish all the success to everyone who is proposing their orbital facilities. And Axiom is the first one, but now the other ones, Blue Origin, NanoRax, and Sierra Space, right? And so it's all great. And now graduates are working there in the field. So they're working in these companies and becoming part of that future. Hopefully, that only means that more workforce will be needed for that. Well, again.
Oh, absolutely. It's wide open right now, and as you said,
Yeah.
it's a very exciting industry. And with all the goals related to the moon and Mars, there's just going to be a lot to offer, and as you said, the workforce is expanding exponentially.
Yeah, and of course, the in-situ resource utilization, so ISRU, that will be again developing, and we got to do that. So on the surface of the moon, especially on maybe potentially with asteroids. So there are many aspects. It's like architecture. in general, the field of architecture, like a discipline of architecture. It's very multidisciplinary itself, if you wish, or because there are so many different ways how you can find your niche in this, being an architect. You can
Sure.
be more like, I was interested in this big system structure, so you can be more interested in historical heritage buildings, or you can be more interested in even landscape architecture, or different types of architectures, right?
Right.
And with space industry and all this young generation that who are in the high school or middle school right now, so for them it's the same thing. So just think about what you're more into it. So if you want to start with your engineering background and pursuing mechanical engineering degree, very generic, and then go to get more information, get more training as a space architect, understand the architecture with that, you can do that, or vice versa. So you can do architecture if you're interested and want to explore that part of space architecture, you can do that and then become a space architect as well.
Sure.
So that is the more you can find, the more information, and you can take more classes. So diversify your knowledge is good, because then it will be easier to really find what is you.
Sure. If you were to guess, and I do have to wrap us up here, but if you were to guess in the future, what would be next after the moon and Mars? What do you think that might be?
A lot depends on propulsion systems, and if new propulsion systems, not only chemical propulsion, will become possible, so then we can go beyond Mars. I'm talking about human missions.
Yeah.
And that's what I really, really, really hope for. So then we can go to Titan or Enceladus or Europa. That would be something.
Yeah. He sounds just like Dr. Howard. He was saying that too. And he said actually there is a new propulsion system. I forgot the name of it already. Kind of like a hydro propulsion or something like that. Very sophisticated, very complicated propulsion system that's being worked on. And if that's becomes a reality, then that would be pretty exciting. And there are some young people that I actually one in particular that's at Georgia Tech, getting her PhD in propulsion systems, and she's probably one of the ones that'll be working on that future type of system. But that makes a whole lot of sense. I guess we need the Star Trek thing.
Yeah, well, the warp, yeah, that would be nice. But before that, probably we just can start with nuclear and thermal propulsion systems. That will be already good, and plasma. Yeah.
Yeah. Well, as with Dr. Howard, I probably could have talked to you for the entire show, just you, to talk about all of the things that are going on in space architecture and the opportunities. But we have to wrap it up, and I do appreciate you joining the show to tell us a little bit about and give us some perspective with the program that you have there at the University of Houston, Cullen College of Engineering. So thank you very much for joining the show, and appreciate it.
Thank you very much for inviting. Yes, and I enjoyed talking to you and talking about the program at any time.
Well, that does it for my 3-part series of interviews regarding space architecture and being a space architect. As you could see and hear, all 3 of my guests are very passionate and excited about what they do, and are looking forward to seeing more aspiring young aerospace professionals explore this very unique and specialized profession. They're also very open to sharing advice with any of you. So feel free to reach out to me, and I will definitely put you in touch. Thank you for joining us. And as you know, with every show, I do my best to provide as much information and exposure to new possibilities for any and everyone who has an interest in any aspect of aviation and aerospace. I encourage everyone interested to consider every possibility and the many options available. You've been watching and listening to All Things Aviation and Aerospace, a presentation of Private Air Media. If you like what you're seeing and hearing, I'd appreciate you subscribing. Until next time, please take care, stay safe, blue skies, and have a good one.